All right, welcome to Thursday. Hopefully you did okay with that homework. Gonna go ahead and call out the answers, check your work, and then answer question one on the Google Forms. How many you got wrong? All right, you had 2 through 16 evens and one proof. How'd that proof go, Caitlin? All right, we'll see. All right, number two is always. Number four is sometimes. Number six is sometimes. Number eight is sometimes. All right, number 10 is 9, and number 12 is 39. Number 14 has lots of answers, lots of answers. 0 points, 1 per point, a circle, a point and a circle, or 2 circles. That's a lot of answers. All right, 16 is 18. All right, the proof, there's probably lots of ways to do it. Here's, hopefully you understood where angle 1 was from the video. Here's how I did it. Well, let's see. If angle 1 is 45, that means that arc PQ is 90. So remember, you have an angle on the circle itself that's not at the center or it's on the circle, then the arc is double the angle length. Okay. So if arc PQ is 90, that means since O is the center, that means O is also 90. So there's your right angle of one of those triangles right there. So if that triangle is 90, okay, well, then that means that check OQ and OP are radii. Therefore, that triangle OPQ is an isosceles triangle. Okay, so if it's an isosceles triangle and O is 90, then therefore that means angles P and angle, hopefully that makes sense of the triangle. Angles P and angles Q have to be congruent because they're opposite the two congruent sides, and therefore that makes it 45 degrees since they would have to be the same measurement. Okay, that's how I did it. There might be other ways. I'd be interested if somebody had a novel way. Go ahead and send me an email. That's how I proved it. All right, so count up how many you got wrong, pause the video, and then answer question number one on the Google Forms, and then come back to the video. Okay, here we go, new chapter. Hey, that was kind of cool, no chapter tests. This particular chapter right here is definitely going to be different than the previous one. And by that, I mean we're just going to get back to the normal chapters. Won't be doing constructions. These are going to be your straight up theorems and postulates. Okay, so we'll do 11.1 today, 11.2 tomorrow. Take our spring break, come back. We'll do PSAT prep, take our PSAT, and move on from there. All right, obviously, I have no idea what's going to happen, but this is the current plan. If it changes, I'll let you know as soon as I do. Okay? All right, here's your homework tonight. Okay, remember you can always pause the video. I don't have to pause. Give you time to write things down. So I'm going to continue with the narrative. I will just continue, but please feel free to pause and rewind if necessary. All right, we are going to start off with rectangles. All right, big picture. Hey, I'm going to basically do a whole section and tell you that the area of a rectangle is length times width or base times height. But remember, this is geometry, so you learned this probably third or fourth grade. And remember, we're not going to let anything into the geometry world unless we actually prove it. And it turns out that proving that that particular theorem is a little bit more challenging than it looks. We're going to do one of the longest proofs of the year just to make that one little proof. All right, we're going to get 3 postulates and 1 theorem today. Okay, so those are our objectives. All right, go ahead and get out your book of truth. We're going to write down some definitions and some postulates and whatnot. All right, in your book of truth, first definition, quadrilateral. I don't know if we've had this written down or not. I believe we did from previous chapter on quadrilaterals. But just so you remember, a quadrilateral is a polygon with 4 sides. Now, go ahead and the small text right there is just a reminder of what a polygon is. A polygon is a closed, that means you can't get to the inside without crossing a segment. Plane, meaning it's on a flat surface. Figure, made up of segments, not curves, segments joined at their endpoints. Okay, so quadrilateral, four sides, and it's a polygon. All right, the first quadrilateral we will study is square. You're like, didn't we do this in a previous chapter? Well, remember, we never did area of any of these shapes, so this is the chapter on area. All right, so a square is a quadrilateral with four congruent sides and four right angles. So remember, a rhombus also has four congruent sides, but squares must have four right angles. And the last definition, the new thing for today is, today we'll be calculating area. And we define area as the space enclosed by a plane figure. Now we'll also be doing circles as well too. That's why it doesn't say the space enclosed in a polygon. All right, so three quick definitions. A picture of what we're talking about. So there's a square. The definition of square is quadrilateral, four sides, 1, 2, 3, 4. Those sides must be congruent, so one tick mark, and I must have four right angles. So quadrilateral, four sides, check. They're congruent, check. Four right angles, check. It's closed. By that I mean, hey, here's four sides that are congruent and not closed. There's also four right angles there. One, two, well, three. There are right angles and it's not closed. That's not a square. And lastly, it's got to be on a flat surface. Got to be on a flat surface. All right, here we go. Postulates. Postulates. I'll give you a quick picture first, and then we'll write down the postulate. So if I have a square, and let's just say we measure one of the sides. All the sides are congruent, and we measure one of the sides, and it's 1 unit long. If I duplicate that square and just stack them, right? Well, if I stack 2 of them by 2 of them, I get another square, right? It would be 2 units by 2 units. I could continue that process. Now I've got 4 units up, and if I stack 4 units across, I get another square, right? So this particular square has a length of 4 units on one side, 4 units on the other side, okay? So the formula for that, since we did stack our squares, since all the sides are the same, well, we just count the squares. It would just be 4 times 4, which is 16. So postulate 17 says the following. It says the area of a square is the square of the length of one side. You take one side, you square it, you get to the final count of how many units. And remember, it's going to be in square. I'll make a note of this in a second. So go ahead and write that down, pause the video. Another one of those duh postulates. Okay, moving on. All right, postulate 18 says this. If you have two figures and those figures are congruent, like triangle A is congruent to triangle B, or triangle ABC is congruent to triangle DEF, then they must have the same areas. Another duh, right? So if they are congruent, therefore they must have congruent areas. So if that, then the areas of each triangle are congruent. This goes to any polygon, to include circles as well, to any shape, basically. If two shapes are congruent, then their areas are equal. Makes sense, right? So far, so good. Pretty easy postulates. Remember, postulates are the ones we don't prove. Postulate 19 says the following. If you have some weird shape, and you take that shape and you break it up into, I don't know, multiple shapes, then the area of the whole darn thing would be the addition of all the individual parts. Remember, we had segment addition postulate, we had angle addition postulate. This is called the area addition postulate. Okay, I keep pausing thinking that I need to give you time to write this down, but obviously you can hit the pause button, so let me stop pausing. All right, a couple more definitions, Book of Truth. All right, first one, rectangle, quadrilateral with 4 right angles. Quadrilateral with 4 right angles. Quadrilateral with 4 right angles. So there's a quadrilateral. In order for it to be a rectangle, I have to have 4 right angles. Now we're going to further define some things. I know you've written down rectangle before in your Book of Truth, but we're going to put some more definitions down that apply to rectangles. You may call any one of the sides the base. Okay. Yeah, typically, in other classes, we talk about lengths and width. Now we're just going to talk about bases and height. So the base could be any one of the 4 sides. Yeah, generally we choose the bottom, but it could be the right or the left or even the top is the base. The distance, and it's going to be measured perpendicularly, the distance between the base and the opposite side we define as the height. I probably should have put a little red square on that dotted line. So yeah, so those 2 basic definitions, base and height, make sure those are in your notes. Height is the perpendicular distance between the base and the opposite side. Okay? All right, so now we did squares simply just by counting squares. Now we're gonna derive the formula for area of a rectangle in a very complicated manner, but we will prove it to you. Okay, and it won't apply just for some; it'll apply to all rectangles. So bear with me with this very complicated proof. It seems really complicated to get to an answer that you already knew and that you've already been using for many years. But remember, no teacher has ever proven it to you. They simply said, hey, area of a rectangle, length times width, or base times height. I'm going to prove it to you right now. All right, so here's the way I do the proof. I want you to, take a piece of paper. Let's do the proof together. You just need to have a, big plus symbol and just do statements and reason. You don't need to redraw the whole thing. And what I'd like you to do is I'll get to a point and I'll say, all right, now pause the video and try. So this is theorem 11-1. It basically says the area of a rectangle is length times width. Length times width. Length times width. Now they're going to call it base times height. Anybody know why they're calling it base times height? Yeah, because as soon as we get to parallelogram, base times height. Triangles, there's a base times height. Trapezoid, base times height. Except there's 2 bases for trapezoids. So it just makes it easier. It's one less formula. If you do rectangles and squares, is base times height. Okay. Note, when calculating the answers, all answers will be in square units. When you calculate area, you're literally counting little tiny squares. We say square unit. That's literally why that 2 there to the second power means square. Square centimeters, square miles. And if there's no units listed, we always just say square units. Okay? All right. So we're just going to do 2 basic practice problems and then call it a day. We call these things composite shapes. Those are shapes that don't have names. They're just made up of many different polygons. Okay. Since now we only know one area formula of a polygon, we can't break this into triangles. We can't break into trapezoids. We will soon, but not right now. So this one, we're going to have to break this down into rectangles. There's 2 ways of doing it. Either one will work. So go ahead and pause the video, get to an answer. What's the area of the entire thing? And then answer question number 2 on the Google Forms. Makes sense? So pause the video, get to the area of the shape, and then plug that number into question number 2 of Google Forms, and then play the video and check your work. Okay. Now remember, there's 2 ways of doing it. Either way gets. I drew the line like this. You could also draw it vertical. By the one postulate said that the entire area is equal to the sum of its parts. So the area of the big shape, whatever that shape is called, would be the area of, well, let's see, I broke it up into a large rectangle and a smaller rectangle. Okay? So let's see. Let's assign some values. Remember, rectangles are parallelograms. Therefore, opposite sides are congruent. Therefore, if the top is 8, that means the bottom is 8. If the left side is 5. Ooh, the right side is not 5. The sum of it, but notice there's a little piece there that says 2. 5 minus 2 is 3. So that means that side length is 3. Make sense? All right, so the area of the big would be 8 times 3. The area of the small would be 6 times 2. 8 times 3 is 24. 6 times 2 is 12. 24 and 12 is 36. And remember, the units will always be squared, so square units. Make sense? All right. How many people broke it down that way? So let's see, what would the big dimensions? For your large one, it would be 6 and 5. And for your small one, it would be what? 8 minus 6 is 2. So it would be 2 and 5 minus 2 is 3 again. So 2 and 3. You still would have gotten the same answer. 5 times 6 is 30. 2 times 3 is 6. You still would have gotten a 36. Okay. All right. Last one. Go ahead and do this one. Pause the video, write your answer into question 3 on the Google Forms, and then come back for the answer. Okay, how'd you do? This is how I did it. I'll show you a different, novel way of doing this one. All right. You could have done it the other way. I'm going to do it this way. I'm going to, yeah, I'm gonna create another rectangle, a large rectangle. All right. So the large rectangle right here would have a side length of 10 and 5. So let's see. This particular one would be large rectangle minus tiny rectangle, right? So area, I call it area of a weird shape. So the area of the weird shape would be area of the large one, the one that I just created with those red lines, large one minus the little tiny one, the red one. Okay. So let's see. Let's assign some values for this little small rectangle on the bottom right. If one side is 2, the other side is 2. Top is 10. The one side is 5. I'm sorry. The left side is 5. On the right side, that little piece is 2. So that means that piece is 3. And so therefore, let's see. If we did the big one, that would be 10 times 5, and the small one would be what? Well, let's see. No, that's 6 times, or I'm sorry, it's 10 minus 6 is 4. I don't have it labeled. I should have labeled that. But the lower piece, the base of the small rectangle would be 4. You can see the top is 10, the bottom is 6, so 10 minus 6 is 4. So I get 4 times 2. I never used that 3. I'm not sure why I put that there. Okay. So let's see. 5 times 10 is 50. 4 times 2 is 8. 50 minus 8 is 42. There are other ways of doing this one. You could have done it the previous way. I just wanted to show you one where I was adding and one where I was subtracting. Hopefully that made sense. Okay? All right. Well, that kind of does it for today. Oh, there's the 4. So my animation was just a little bit off. Okay. Well, that does it for the day. We did 3 postulates. We did 1 theorem. Basically, the so what of everything is area of a rectangle. So the homework tonight shouldn't be too challenging. Go ahead and do that. If you have any questions, don't hesitate to ask me a questions. And I will see you tomorrow, Friday, last day of the week, and then spring break.